All right, in this video, I want to just talk about the steps that we go through in doing an optimization problem. So I've got them written down on the board here, and I just want to talk through them. So the first thing is to identify the quantity that you want to optimize. Sometimes that's maximize, sometimes that's minimize, and just write a formula for it. Usually at this point in the problem, that's going to be a formula that involves more than one variable. That's okay, that's our starting point, okay? But I find it really helpful to just at the very beginning say, what do I want to maximize or minimize? And just say, my goal is to maximize or minimize this. Because a lot of times, you've got two different equations once you write your constraint, and a lot of times I see students getting those confused. So labeling, my goal is to maximize this, that's the one I'm going to be taking the derivative of, can be helpful. All right, step 2 is to write the constraint. That's the thing that you can't control. It might be a limitation on the resources that you have. It might be a practical situation that certain things can't be negative in the real world. You're going to write down that constraint. Okay. All right, and I would label that it's the constraint so that you don't end up trying to take the derivative of that. Then you're going to use the constraint and solve for one variable in terms of the other. Okay. Then you can plug that into the equation from step 1, the equation for the thing that you want to max or min. Your result is super important. That gives you the quantity that you want to maximize or minimize, but it gives it to you as a function of one variable so that we can do some calculus. Okay. Then, step 4, you're going to state the domain. Now, I'm sort of circling that step because it's easy to forget that step. It's easy to get the right answer if you do forget that step, just because all the problems in the homework are kind of nice. Okay? The real world isn't guaranteed to be nice. So the domain is important because it's generally not going to be the natural domain of this function. Often, mathematically, whatever equation you get in step 3 would be defined for negative numbers, but often the practical situation requires that things be non-negative. Okay. The other reason the domain is so important is because it's going to tell us what technique to use for finding a max and min. If I'm working on a closed interval and my function is continuous, I know I'm guaranteed that there is a max and min. I just have to check endpoints and critical numbers. If I'm working on an open interval, I'm not guaranteed to have a max and min. What I would have to do is hope that I have just one critical number and then look at the shape of the graph. If the shape of the graph, in the last case, we had just one critical number, okay. If the shape of the graph gives me a min at that point, there's no place that the function could possibly go lower than that on that interval, so it's guaranteed to be an absolute min. Okay. We're not going to encounter any open intervals where you've got more than one critical number. If you did, and the function changed signs, what you would have to do is take a look at the limit as you approached b, whatever this endpoint was, whether it was a finite endpoint or infinity, to see if the function actually did go lower than the value at this relative min. We're not going to have to deal with that, but I just wanted to mention that's what you would do. Okay. So you use the appropriate technique then to find the max or the min. Once we know whether we're on an open or a closed interval, that determines what technique to use. Again, that's a step that students often skip. They find the critical number, and because these problems are relatively nice, all of these problems, well, I guess there are a few problems where the max or min occurs at an endpoint of a closed interval. Okay, but almost all of the problems, there's one critical number and that's the location of the max and min, so you get lazy, you get sloppy, and you say, oh, the critical number is my answer. And you happen to be right, and then you turn in work on a quiz or an exam, and you have the right answer, and you get like half the credit because you didn't actually verify that you had a max or a min. So don't forget that step. And then, always with any application, the last step is to answer the question. And you do sometimes need to go back because sometimes you're asked, what are the dimensions of this thing? Sometimes you're asked, what's the area or what's the volume? Sometimes you're asked just, what's one of the dimensions? So make sure you read the question to see what you were asked for. And always we're going to include the units in our answer. And the units just have to be consistent. If I'm measuring a length in meters, any area would be in square meters and any volume would be in cubic meters. So use the same base unit for all things and just match the dimension of what you're talking about. If it's a length, it would just be plain old meters. If it's an area, it would be meters squared. Okay, back for another example in a minute.